So kind of doing the same thing we did in question 4, we have two functions here, f of x equals x squared, which is quadratic, and g of x equals x squared plus 4. It's also quadratic, actually. So find the following composite functions and state the domain of each. So if I want to evaluate f of g of x, so notice how f is the first function, g of x is actually the one that goes into the f function. So again, f of x was equal to x squared, and g of x was equal to x squared plus 4. So what happens is, if we look at it from a model, f is our function. And what's happening is the g of x is actually what's going on from here. So we actually have f of, and then g of x is actually this x squared plus 4. So g of x is actually going to be this x squared plus 4. So that becomes our input. So this x squared plus 4 is actually going into the function. The function it's going to be going into is the f function. Well, the f function just says square the input. So the f function you're going to have in parentheses, and then this x squared plus 4 is going to go in there. But that still has to be squared. So that's the math that we have to do, is this x squared plus 4 squared. Now, since it's a binomial square, it's actually just going to turn into a trinomial. So the first move is have x squared squared. So you have x squared, and you're going to square that. And then the next move is to multiply 4 times x and double it. So you should have 2 times 4 times x squared. And then the third move is to square the last term. So we're just going to be squaring a 4. So if we do the math, x squared squared means there's an x squared twice, which means there's 4 of them. So a power to a power, you can actually multiply. And then 8x squared plus then 16. So this actually becomes a 4th degree function. But I still don't see any domain restrictions in this problem. So our domain is still going to be the set of real numbers there. So next we want to evaluate is g of f of x. So remember, f of x was equal to x squared, and g of x was equal to x squared plus, what was it, plus 2, plus 4. So g of x is x squared plus 4. So this time they want us to evaluate g of f of x. So this becomes g of f of x. So what we kind of pick up on is, when we do this, the f of x function is going to become the input. It's what's going to go in for x in the other function. So that's the uniqueness of a composite function. So this actually becomes g of, and then f of x actually is this x squared. So if I look at this from our model, so we're actually dealing with the g function. But what's going in is this x squared. But the g function is something squared plus 4. So something squared plus 4. So what's going in place here is actually the x squared is going in 4x. So if we do the math, x squared squared is actually going to be x squared to the, or x to the fourth power, I should say. And then we just add the 4 since those are not like terms. So this becomes then x to the fourth plus 4. Again, notice that there aren't any domain restrictions, so the domain is going to be all real numbers. So again, notice how we have this g of x squared is what we're basically dealing with. So that means that if I'm looking at this, we're using the g function, but notice that what's happening here is the x squared is going in place of x. So where there's an x, that's going to turn into an x squared. And then that x is still being squared. So if we do the math, x squared squared is x to the fourth plus 4. So notice how that's kind of how it plays out there. So if I want to evaluate f of x, again, f of x was the x squared function. So we have f of x. So notice how this turns into f of, and f of x is actually this x squared. So we have our f function. X squared is going in. And then if we pay attention to our f function, the f function is something squared. So something squared. What's going in for something is the g function, which is the x squared. So if we do the math, x squared squared is just going to be x to the fourth. So x to the fourth will be coming out. So f of x is going to be x to the fourth. So notice how, again, we do not have any domain restrictions. It's all real numbers. So if I was just going to do it, it would be like f of x squared. But notice how the x squared is what's going to replace the x in the f function. So the f function is x squared. So this x here is getting replaced by this x squared. And so we have x squared squared. X squared squared would be x to the fourth power. So g of x, we're going to have g of x was x squared plus 4. So what we have is g of x squared plus 4. So notice how this x squared plus 4 becomes the input. Remember, the input always replaces the x in the function if x is the input. So again, I'm just going to do the drawing to kind of help me out here. So I have the g function, and what's going into the g function is this x squared plus 4. The g function, notice that this is the x, so we're going to leave that. That's where our blank is going to be. And since it's x squared plus 4, we're going to make it a little bit bigger. And then we have that adding of the 4 here. So what happens is this x squared plus 4 goes into the function. And the function says square it and then add 4. So essentially what we're doing is going x squared plus 4 squared, and then we're adding 4. So if I'm following the pattern here, since this is a binomial square, we just square the first term. So it's going to be x squared squared. And since next term you multiply those two together and double it, so it's going to be 2 times 4 times x squared, or 4x squared. And then we just square the last term, which is 4 squared. And we still got to add a 4 to that. So x squared is x to the 4th. And then we have plus 8x squared. And then we have 16 plus 4. So we have x to the 4th plus 8x squared plus 20 would be our new function. So g of x is going to be x to the 4th plus 8x squared plus 20. Again, there aren't any domain restrictions for this function, so it's going to be all real numbers. X does not appear in the denominator of a fraction, and there's not a square root symbol present either, so that would be what we would have there. Okay, so that concludes question 6, I believe.